Hi everyone, my name is Alagappan and I'm a PhD candidate at the University of California, Irvine. The paper I'll be presenting today is titled Nautilus, a framework for cross-layer cartography of submarine cables and IP links. Submarine cables form the backbone of the internet infrastructure, carrying more than 95% of the intercontinental traffic. However, this critical infrastructure is vulnerable to natural disasters and damages due to human activity. In March 2024 alone, two significant incidents highlighted the fragility of this infrastructure, which were the damages to three undersea cables in the Red Sea attributed to human activity, and the damages to four cables off the west coast of Africa attributed to undersea seismic activity. And each year, there are more than hundreds of submarine cable failures that happen. And the impact of these failures is further amplified at the higher layers of the internet. This is because multiple autonomous systems or ASs often share a single cable, each with numerous IP links on the cable. Consequently, when a cable fails, all the IP links relying on that cable are affected. Despite the critical importance of submarine cables, we have a limited understanding of how their failures affect end-to-end internet connectivity. And prior works were largely limited to specific layers of the internet stack, like physical cable map or an AS map. However, no cross-layer map for submarine cables exists today. Introducing the solution, Nautilus. Nautilus is a cross-layer mapping framework that maps submarine cables and IP links. The key features of Nautilus include it's a global internet scale mapping effort. All Nautilus mappings come with a prediction score to capture the certainty in the generated mapping. Nautilus can handle complex mapping scenarios such as parallel cables where multiple cables exist between two given locations. And finally, Nautilus mappings are validated with multiple techniques. In summary, Nautilus generated a cross-layer mapping of 4.5 million links spanning 90% of all active submarine cables. Now let's look at how Nautilus generates mapping. Nautilus generates its mapping based on two properties. The first one is geolocation, where the rationale is that IP links are more likely to use the nearest available cable infrastructure. As IP geolocation, especially at the city level, is known to be inaccurate, and no single source has complete coverage for all IPs, Nautilus employs 11 different IP geolocation services and validates the geolocations using a test based on the speed of light in fiber optic. The next property is ownership, where the rationale is that the IP link is more likely to use a particular cable if the corresponding AS owns or operates that cable. Now let's look at an example of how Nautilus employs these two properties to generate mapping. Let's consider the following shown IP link, where we call the endpoints as IP1 and IP2 for simplicity. Using our 11 geolocation services, for IP1, we get the results from 10 services, where 2 point to a location in Taiwan and the rest of the 8 point to a location in the US. Of these 10 geolocations, only the 2 results from Taiwan pass the speed of light test. Similarly, these are the results for IP2, where our geolocation services point 6 location in California and 4 in Kansas. And all the 10 locations here have passed the speed of light test. Now, Nautilus looks at all possible combinations of the locations for a given link. Thus, the first combination here is IP1 in Taiwan and IP2 in California. For this specific combination, based on the geolocation property of using the nearest available cable infrastructure, we get the following 5 cables. For the other combination of IP1 in Taiwan and IP2 in Kansas, we have no cable mappings as the Kansas endpoint is far inland. Thus, for our cable candidates from the geolocation property are the 5 cables shown in this figure. Next, moving on to the ownership property, the figure here shows shows a few cable owners for each of the 5 cables. And employing the IP to cable owner mapping with the ASN or autonomous system number as an intermediate, we get that both IP1 and IP2 are part of the Google network. So based on that, we see that only PLCN and Faster, where Google is one of the owners, are the more likely choice for this specific link. And Nautilus additionally computes a score for each of its mapping as shown in the figure. Now that we have seen how Nautilus does its mapping, let's look at one of the techniques Nautilus uses for validating its mapping, which is its past cable failures. The rationale here is that when a submarine cable fails, all the links mapped to it should disappear from trace routes collected during the outage period, but be present before and after the outage. So based on that, we collected the data for a 4-day outage in Yemen in 2022. The results from this experiment show that before and after outage, the number of links are close to 100, while it being only 5 during the outage, demonstrating Nautilus's mapping efficacy. For further understanding of Nautilus validations and results, we encourage the readers to consult our detailed paper, codebase, or website. Thank you.